Hi everybody, welcome to Wes Explains Best. Today we're going to do parallel and perpendicular lines. I said in a previous video that I really wanted to do another video that shows point slope form and how it's super useful for finding the equations of this. So this is another Kuta tutorial on parallel and perpendicular lines. We're still asked to find it in slope intercept form, but I really want to emphasize the point slope form method, which I think is a lot easier and a little bit more versatile. So the first thing I'm going to do is I'm going to show how we do it in slope intercept form. For some reason, it's been my experience that students don't really like doing it this way, or it confuses them, where point slope is a lot more straightforward. So first, again, let me show you how you do it. First, we're going to label our x and y. This is the point that it goes through, and we know it has to be parallel. So I'm going to use this green color to this line right here, okay? Now, when it says parallel, we're interested in the slope, and with parallel lines, we want slopes to be equal for parallel lines. So we know that if we're going to input this stuff into our new equation, we know that we're going to choose 2 over 3 for our m, which is our slope. So we're going to keep the m the same. All right. Now our equation, we're going to have, it's still x, it's still plus b, it's still equals y, but we have 3 inputs or 3 variables here, and we really need a y-intercept. So that's what you have to solve for when you're doing it through the slope-intercept form method, is you have to solve for your b. How do you do that? What you do is you replace your, is that partial whole? There we go. You have to replace your x with the x that's given by the point, and you replace your y with the y that's given by the point. Let me show you what I mean by that. We're going to put the 3 here because that's what the point is, and then we're going to put 0 in for y because that's the y value of the point that's given. After that, we just solve for b and we get our y-intercept. So we multiply 2/3 times 3. If you want, put it over 1. You have top times top, 6 over 3. Plus b equals 0. 6 over 3 is 2. Plus b equals 0. 0. Then we subtract 2. Subtract 2, we get negative 2 equals b. So we have our y-intercept is negative 2. So if we were to put it all together, we would have the equation y equals 2/3 x. It's got to be the same slope, minus 2, because it's got to go through this point, and we solve for the y-intercept. So there's our equation, okay? Some things that students don't like about this method, from what I've gathered, is they don't like having to input x and y. Okay, they forget to do that. They don't understand why they do that. They don't like solving for b and then having to plug it back in. It's just a lot of movement. So let me show you another method that I think is a little bit easier. And let's go ahead and jump into it. Now for this second method, well, I'm just going to do the same problem again. Let me erase some things here. We're still going to use some of the basic principles, except that this time we're going to label this x1. It's basically still the same thing, okay, and y1. Okay, it's the point. It's a point that this line goes through. It's same ordeal, but we're just giving it a slightly different name. Now the equation of point slope form is y minus y1 equals m times x minus x1, and that's in parentheses. Okay, so it's pretty much the same thing as we did before when we were plugging into slope-intercept form, but now we're plugging into point slope form. So what we're going to do is we're just going to replace all the values that we know. Well, we know our slope needs to be the same, just as it was before, our m. So we're going to change that to 2/3, 2 over 3. Okay. This time we leave the x alone. We leave x there, but the x1 we change to our x1 value, which we labeled in the beginning, which was 3. So we have x minus 3. Keep in mind that this formula, probably the most confusing thing is it's minus. Okay, it's derived from the equation for slope, and that's why it's minus, because you do y2 minus y1 in the top. Anyway, that aside, make sure you're copying down that it's minus, so if it's a negative, it's going to be minus a negative. That's something just to watch out for. So we keep the y, and the y1 that we labeled is 0. And we hit equals, or not hit equals, we put equals. Now, what's the difference? Well, we don't have to solve for a b here. That's what students like a lot. They don't have to solve for that b. There's nothing to worry about. But all we need to do is simplify from here. So then it just becomes, once you plug in, which we just did, we plugged in all our values, now it's just simplifying. So y minus y, 0 is y. We have 2/3, and what we can do is we can distribute here to get it into slope-intercept form. Now, a point of interest. If it just asks for an equation, it doesn't matter if it's point slope or y-intercept or all that. That technically is an equation of a line that's in point slope form, and you're done. So it's just really easy putting in our values into point slope form, and then you're done. Okay, that's what I really like about point slope form. But because it asked to be in slope intercept form, I'll show you how to do that. We essentially just solve for y and simplify. So I'm going to distribute the 2x, or the 2/3 to x, and I get 2/3 x. And then I distribute the 2/3 to minus 3. So I do 2 over 3 times a negative 3 over, what is that? 3 over 1, okay? If you want to make it top times top, you get negative 6 over 3, we get minus 2. So as you can see, we got the same answer, but in my opinion, it's far fewer steps. It's much easier to do point slope and then convert later. Let me show you just how easy this is. We're going to do, let's skip down to a perpendicular one. So these are all parallel. You're going to use the same slope. Let's go ahead and do number 9, perpendicular. Okay, so again, we have this. We're going to use point slope from now on. I'm probably going to do 2 more. We're going to label this x1, y1, just as we did before. That's one of the steps. Okay, we identify our current slope, but this time we want it to be perpendicular. So what does that mean? Well, perpendicular slopes have opposite reciprocal slopes. I just abbreviated opposite reciprocal. That means we make it negative and then we flip the numerator and denominator. Okay, so if we have 1/3 as our current slope, this is going to change to, so it's positive 1/3, so it's going to be negative, and then we make it 3 over 1 or just negative 3. So we have our new slope here, which is negative 3. So we're ready to roll. We have y minus y1. This is the general form for point slope form. Okay, and we're just going to plug in our values. So our first thing we'll put in, we can put in negative 3 for our slope. Okay, we leave the x, we leave the y, and we subtract a negative 1. Okay, this is what I said you got to be careful with, the negatives. And then we subtract a positive 5. So we just minus 5. Now we simplify. We clean it up a little bit, as I like to say. So we do y plus 1 equals negative, and we can distribute if we're trying to get into slope-intercept form. If you're just leaving it in point-slope form, it would just be this. Okay, so if your teacher or the problem set does not specify what form it has to be in, this is technically it. You're done, which makes this super easy because all you do is label and plug in after you calculate the opposite reciprocal slope if it's perpendicular and the same slope if it's parallel. Now, if it's asking for a slope-intercept, then it's just one more step, which isn't too hard. We distribute, and then we subtract 1 to both sides. So we get y equals negative 3 times x is negative 3x. Negative 3 times negative 15 is positive, or negative 5 is positive 15, and we still have to subtract 1. We get y equals negative 3x plus 14, and we're done. So it's really a lot fewer steps than it would be if we did it the other way in slope-intercept form. Let me do maybe one more. Okay, let's hopefully go to a hard one. Let's go here, because it doesn't look like we have everything. So we have 16 perpendicular to y equals negative 8x. Okay, so what we're going to do here is we are going to highlight our slope, and we know we want to make it perpendicular. So we're going to go from negative 8. Okay, and what do we change that to? This time I'm going the opposite direction. Well, if this is 8 over 1, we're going to make it positive 1 over 8. So that's my new slope. Okay, so now I'm going to label my points. I have x1, that's my x value of the point. Oops, this is my y value of the point. So I have y minus 4. I'm just going to use one color so you can see that it's fairly quick. I have 1 over 8 is my slope, and then x minus 5. Okay, it's not in slope-intercept form, but if it was just point-slope form, again, you'd be done. This is in point-slope form, and you're good. That's an equation of a line that is perpendicular. That easy to get an equation, okay? If you want it in slope-intercept form, you want to find out the y-intercept, again, we just solve for y. So what we're going to do is we're going to distribute, which is going to be a little messy in this case. So we have y minus 4 equals 1 over 8x minus, and now we're going to have 5 over 8. We multiply negative 5 times 1 over 8, we get 5 over 8. We have to multiply or add both sides to 4 to both sides. We have 1 over 8x. And now we're going to have to find a common denominator. So this is probably a tricky part about this form, but you'd have to do this anyway. You'd have to solve for your y-intercept anyway, which is going to involve some fractions. So it's not like this method is causing you to have fractions. It's not. It's just you'd have to do the fractions anyway. So just keep that in mind. Now we want a denominator of 8, so we're going to multiply 8 over 8 to 4. So we get 5 over 8 plus 32 over 8. Now we can combine this to equal 37 over 8. So plus, oops, that was a negative 5 over 8, wasn't it? Okay, so we have to subtract those. That's actually, was that 27 over 8, and they don't have like terms, common factors, so we're plus 27 over 8. There's our final answer in slope-intercept form. Okay, it's that simple. Hope you guys enjoyed this video. I hope you found this helpful. Keep in mind, parallel slopes are the same. Perpendicular slopes are opposite reciprocals, and I'll see you next time on Wes Explains Best.